Learners, welcome. Previously, in Form 4, Lesson 12, we are dealing with the water hardness. In Lesson 13, we are dealing with methods of removing hardness of water or water hardness. So I told hardness can be removed by various methods or it can be removed by various ways. Which include one, boiling. So I told this method removes temporary hardness only. So during boiling, calcium hydrogen carbonate and magnesium hydrogen carbonate in the water or in the hard water are decomposed to produce the insoluble carbonates. That is the insoluble calcium carbonate and magnesium carbonates. Remember, we are told in Form 2, all carbonates are insoluble except group 1 and ammonium carbonate. So number 2, distillation. We are told this method removes both types of hardness, that is both temporary and permanent hardness, but the problem is it's expensive when you use large amount of water. So during the exam, you can be told, give the disadvantage of using distillation as a way or a method of softening hard water. So we say it's expensive when you use the large amount of water. So number 3, we're having addition of sodium carbonate, which we can say soda ash. This method removes both types of hardness. That means both temporary and also permanent hardness. So we are told the calcium ion and magnesium ions are precipitated out. So if we write a full example or full question of temporary hardness, we're having calcium hydrogen carbonate reacting with sodium carbonate, giving you calcium carbonate and sodium hydrogen carbonate. So the ionic equation will be like this: calcium ion reacting with carbonate ion, 2 minus up. We are going to get calcium carbonate, which is precipitated out. So that means that water has no ions of calcium, which cause hardness of water, so it is softened like that. So here we're having magnesium ions reacting with carbonate ions in the sodium carbonate to give you magnesium carbonate, which precipitated out magnesium ions. Hence, the water there is softened. So number D, we're having addition of calcium hydroxide, which is known as lime water or slacked lime. We can also say the slacked lime. So I told this method removes only temporary hardness or temporary hardness only. So a fixed amount of or a treated amount of calcium hydroxide is added to water containing calcium hydrogen carbonate and that magnesium hydrogen carbonate. And magnesium hydrogen carbonate. Calcium hydrogen carbonate is precipitated. So if excess calcium hydroxide is used, it reintroduces calcium ions in solution, making the soft water hard again. So you're told a fixed amount or known amount of calcium hydroxide should be added to the water containing the hard water. Okay, the equation for this is calcium hydrogen carbonate reacting with calcium hydroxide, treated amount of calcium hydroxide giving you calcium carbonate, which is precipitated out, and also water. So that water formed is softened like that. Then number 5, we're having addition of aqueous ammonia or ammonia solution, and we are told this method removes only temporary hardness. So aqueous ammonia is added to water containing calcium hydrogen carbonate, which precipitated out as calcium ions. Or we can use water containing magnesium hydrogen carbonate, which precipitated out as magnesium ions. So the question here is calcium hydrogen carbonate reacting with ammonium hydroxide or aqueous ammonia, giving you calcium carbonate, which is precipitated out as calcium ions, and also water and ammonium carbonate. Okay. Thereafter, we go to Romeo 6, because that's Romeo E. We go F, and F we have the ion exchange. So this method removes both types of hardness. We are told the hardness is passed through a column fitted or filled with a complex compound of sodium known as sodium permutate. So it is written Na2X. That means the valence of the X there or the anion is 2. So we are told as the hard water is passed through the column, magnesium ion and calcium ion are exchanged with sodium ion in the column, thus softening the water. So the equations for that will be sodium complex reacting with calcium ion and magnesium ion, giving now calcium complex and magnesium complex, which are fitted in the column. Then that means sodium ions goes with the soft water. So I told as the process continues, the column is converted to calcium complex and magnesium complex, hence loses the ability to soften water. So during the exam, we are told, how will the column be regenerated or recharged? We are told the column is recharged or regenerated by washing it or by flushing it with brine or concentrated sodium chloride solution. So to write that question, we're having calcium complex solid plus sodium hydroxide, which is now concentrated brine. We are going to get calcium chloride and also that sodium complex. So that means the column is regenerated now, or it has been recharged, because it's having its initial components. Okay, let's see how that column look like. So we're having here, so here we are having the first one, had water containing calcium ions or magnesium ions, which were causing either temporary hardness or that permanent hardness. So in the column, we have here ion exchange column before hard water is passed through. So it was having sodium ions in it. So what happened was that calcium ion and magnesium ions exchanged with sodium ions now in the column. And these sodium ions bases with the soft water. After that hard water being softened, we have here soft water containing sodium ions out. If we check this other one here, we are having a ion exchange column after hard water is passed through. So that means the sodium ions has already gone with the soft water. That means calcium ions or magnesium ions remain in the column. That's why after some time the column needs to be recharged or regenerated by washing or by flushing it with the brine or concentrated sodium chloride. Thereafter, we go to extended questions. We have around 5 extended questions. As you can see, that's the end of our